In this video, we'll show you how to solve a system of linear equations by a strategy called elimination. In our first example, we have two linear functions. We're asked to solve the system by elimination. Notice these lines are not written in slope-intercept form. If they were in slope-intercept form, I could graph them and find the point of intersection of the two lines. These lines are in standard form. ax plus by equals c. And I notice that if I were to add these two equations together, the x terms would cancel out because they're additive inverses. If I add my y terms together, I get 8y, and 9 plus 7 is 16. So my system of equations became a very simple equation to solve for y. We can divide both sides by 8, and we get y equals 2. So the y coordinate of my solution is 2. Now I can use either equation that was given. I'll pick the top equation because it doesn't have any negative signs. I'll put the value of y equals 2 into that top equation. Now I'm going to do the math here. Multiply 2 times 2 to get 4 and rewrite my equation. I'm solving for x, so I'll subtract 4 from both sides. I want to undo multiply by 5, so I'll divide by 5 to both sides. And I have an x and a y, so my solution, which is always in the form x comma y, becomes 1 comma 2. If I were to have graphed these two lines, the lines would have intersected at the point 1 comma 2. That is the point that lies on both lines. We'll do a second example now. Once again, these lines are in standard form. ax plus by equals c. Notice the x's and the y's and the constant terms are above one another. If I were to add these two equations, neither the x terms nor the y terms would eliminate. However, if I could multiply one of the equations by -1, I'll pick the bottom equation and rewrite my bottom equation as -2x minus 3y equals -5. Now I can add the two equations, and you will notice that the y terms will cancel out. So when I add my x terms together, I get 5x is equal to -10. We can divide both sides of the equation by 5, and we get x equals -2. That is the x coordinate of my solution to this system of equations. Now remember, we can use either of the two given equations. I'll pick the bottom one because the numbers are smaller and there's no negatives. Let's take the x value of -2 and substitute it in place of x. Let's multiply 2 times -2. We're solving for y, so underneath -4, we'll add 4 to both sides of the equation. This equation becomes 3y equals 9. Let's divide both sides of the equation by 3, and we get y equals 3. So the solution to this system of equations, again always in x comma y form, is -2 comma 3.